Please pause the video and take a moment to read this important safety message.
Alright, welcome back everybody. Part 2 here in this night KB or KG85 amplifier restoration. We've got all our parts in stock now and we're going to start kind of working our way through. I'm going to start with the can caps here on the back side and kind of work our way forward in this direction, and have to tame these beasts right here. Can't wait. Okay, the first thing I did here was the 60 microfarad at 450, I kind of marked down what the symbol was on the bottom of it, and then I went and figured out what the, and Hayseed gives you a little sticker map here. You can stick on the, you can actually put them on the cans if you want, or you can put them inside your amplifier. But luckily enough, all these match up the same, so it's going to be really easy. Now what I don't know is whether they're laid out in the same order here on the bottom of the cans as they are the bottom of the new Hayseed can, but we'll figure that out here in the next step. And if it turns out, if you look down in here, it's round, square, triangle, none. And if we look on the bottom of this, now it's round, square, triangle, none. So they made these exactly to match exactly what I need here. I'm going to get this out. Okay, as you can see, I always draw these out, and I know it looks a little bit like chicken scratch, so I'm not going to post this online for somebody to copy later. I think it's best for each person to draw them themselves, and because they draw them, they will have it in memory exactly what they drew, and it'll make more sense to them if they go through the process. But basically, this is the cap on this side, this is the cap on the other side. There's a couple interconnects, but I've kind of drawn everything out here and kind of colored and labeled it, and what we're talking about, just so you can see it here, is this can cap down in here and can cap here. Now, I did go in and mark on the chassis down in here, like the triangle is that direction, the bottom corner there, whereas on this one the triangle is over right here, so I've marked that. That way when I go to insert them, I'll get them right, and then when I wire up all the right wires, we'll get them right. Okay, I just used some wire snips and I cut all the wires loose. Some people go to the extent of unsoldering them. I just find it a little messy. I like to cut them and strip the ends and have a nice new solder connection. Up next, I'm going to use a flat nose pair of pliers here and try to straighten out all of these little tabs that'll go down through this phenolic wafer. And if for whatever reason those wafers get broken, Hayseed provided some new ones here. And just for the record, since these are kind of mirror images of each other and the wires mirrored up, with the exception of two wires, they're identical, two grounding wires, they're identical. I'm going to leave this one intact till I get this one done as a reference, and then I'll go do the other one. Alright, and out it came. I did use some little angle nose pliers here to kind of get down in and snip the ends of these off, the ones that had solder on them. But other than that, it was a fairly easy task to pull that out. Now we can put the new one in. Now if you'll notice, Hayseed covered the outsides of the cans on this. It's okay. It could have been my mistake. I could have checked the box where I wanted the can covered on the outside, but both of these are can common negatives, if you'll notice. Can common negative and can common negative. They just put the outer sleeve on it, which is fine. I kind of like the looks of it, actually. Okay, when stripping these little wires, I like to hold them with a pair of flat nose pliers on one end and then just kind of use my wire strippers on the other. Otherwise, you risk pulling this wire back out through that goes way down here on the other end to a preamp board, and I don't know, just helps keep things intact. Okay, if you'll notice, one end of the wires that I need to strip that connects down here is the other end of this big, large capacitor. While I'm doing that, I'm not going to strip this and solder it back down. I'm just going to put the new one in and solder it in instead. Also, this new replacement cap from CE Manufacturing comes with this neat little sticky pad and a zip tie here. I'm going to end up sticking that on top of the transformer so that this will get held in place right here. Okay, as you can see, we got this mounted in here. I got one end on the other side here soldered down to where it went. The other end I've just stripped, and all I'm doing now is stripping all these wires. Well, I got to this wire, and this wire goes between the ground lugs of these two capacitors. one on each side, and I decided just to pull this out because this is like a bare wire inside of a sheath, and I'm just going to run a new piece of PTFE wire between these two. This is really hard to work with because it's kind of rigid. Okay, we're getting some wires bundled in here. Get things heated up. And all soldered into place. Okay, to replace that one ground wire between the two caps, keep in mind these caps are floating. They're not grounded to the chassis. The whole ground bus on this amplifier is not grounded to the chassis. Anyway, just some 20 gauge PTFE wire, silver plated copper is what I'm going to use. Okay, as you can see down in here now, we've got it all soldered up nice and neat. Just put everything back the way it was originally. And we're ready to move to the other side, and you can see I've already got the cap here installed in between and soldered up on both ends. And I'll be able to see this, but sometimes I use a Teflon cooking board, like you'd buy at any restaurant supply, or I found this one actually at like a TJ Maxx or Home Goods. But the beauty of it is I can spin this amplifier around on my table, even though this thing weighs a ton. And I can move it around and turn it as I'm soldering, and it slides easily on the table here, and it keeps the amp from getting scratched up in doing so. Okay, we got can cap number 2 out. I'm going to leave this bus wire here intact, and because it runs all the way down, the ground bus runs down the length of the amp, and I'll solder it back down. I will tell you, this one's a little harder to get out than this one because you've got the power cord right in here that's coming in. You got the power switch, you got the cord coming in right here. All that right here kind of gets in your way, but it's very doable. I will tell you, replacing both of these caps, you know, it's probably about an hour and a half's worth of work if you're good at it. It's not a 10-minute job, I'll say that. All right. I'll do my best McConaughey impression here. Got all these soldered up. Double checked everything, triple checked everything, got this capacitor here replaced and strapped into place there, and now we're going to move on down. I'm scared of these. Not really, but they're not my favorite. We're going to tackle these boards next, and let's get into that. Let's take a few minutes and talk about restoration approaches in general, okay? We're going to start over here with these electrolytics. There's no scenario where I'm leaving 55, almost 60-year-old electrolytics in an amplifier and trusting them to carry us forward. These things are just notorious for failure. They're electrochemical devices. They dry out over time, and what happens is you have failure then at that point. One of these was already starting to leak right here, if you can see it, out the top of this capacitor lug, the black ooze that you get, because these things over time build up internal resistance. What does resistance do when you apply voltage across it, right? It dissipates heat. What happens when you dissipate heat? Causes these to dry out even more. So the more they fail, the more they generate heat, the more they dry out, the more they fail. Sooner or later, it's a catastrophic failure for you. Same with this here. So these were getting replaced, okay? Then you've got caps that are coupling capacitors, okay? And as much as I would like to leave old coupling capacitors in an amp, because I do think they help define somewhat the sound of that amplifier. In other words, you take an old Macintosh unit and it's full of bumblebee capacitors, and you replace them all with modern polypropylene coupling caps, and yes, this unit will last many years. Might sound slightly different than it did the day it left the factory. It's hard to replicate some of these old capacitors, their tonal attributes. Any rate, here's a scenario where there's no way I'm leaving these red ones. These are the plastic encased wax paper capacitors, notorious for failure, and we've got 4 of them here, okay? Then you can see somebody over time has replaced this 2 microfarad here with a modern polypropylene film cap, okay? The problem is over here, This is some type of paper and oil, so I don't even have the same between the two channels, okay? So I'm definitely going to replace these. By the way, these little blue ones right here, these are electrolytics, and if I'm not mistaken, yes, these are non-polarized electrolytics, so we're going to replace those. Then you get to the most pivotal question, and that is, what do we do about these old resistors? There's kind of a couple different approaches you can take. One approach is I'm going to replace them all, and I call that a shotgun approach, and it will work, and it will yield you an amplifier in spec that will last a long time. The downside to that is there again, you may change the tonal attributes of this unit. These old carbon comp resistors have a soft, smooth sound to them that gives a tube amp a lot of its warmth. Okay, you go replace this with new metallized resistors, metallized film resistors, and you might end up with a different sound to the amplifier. So I fall somewhere in the middle typically when I do this. And sometimes it also, don't forget, it's up to the customer, okay? So if I had talked to the customer and gave them a few options, they might have went and erred on the side of longevity and having all new parts in this amp, and they wanted a total restoration. They could have went on the other side of it. Hey, only replace exactly what is out of spec or broken, right? And that looks like the approach that was done here. So, you take an amp into a shop and you say, hey, I want to get my amp working, it stopped working. Well, my friends, this is the typical approach. Hey, this cap looks bad, and by the way, that's not even soldered. Look at this. I don't know if you can see that or not, but I can see why this amp, look at that. I can see why this amp might have been having problems here. But that's what you get. Somebody just replaces the one bad component they found. And in another case, somebody replaced this one here. It's an approach at getting, it's like taking your car in and getting the alternator replaced because it stopped running. That's very different than taking your classic car in and saying, I want a full restoration of my car, right? So I'm somewhere in between. I'm the customer, this is my amp. So what I'm going to do is measure these, and any that are out of spec, I will replace. Any that are in spec, I'm going to try to leave in place just for the tonal qualities that it will, that it will maintain by leaving those in here. And resistors are much less likely to just dry out and fail you. That's not the way they work. They're not an electrochemical device. They're not made like these old wax paper that, it was impregnated with wax. Think about that. Over time, what happens? It dries out. That's exactly what's happened to a lot of these old, like sleeves in here. They're just old and brittle because they're hard. So, at any rate, a couple different thoughts there, a couple different approaches. I'm going to take the fix what needs to be replaced from a resistor standpoint. I'm going to replace all the capacitors and all the electrolytics for sure. All right, a little more specifics here on our approach. We got a little bit of a quandary here to deal with, okay? If you'll notice, this is page 13 of the assembly manual you can download for this amp, and there's good schematics in it as well as nice, neat parts layouts, okay? Well, here, look at this. We've got a 0.25 microfarad at 400 volts here. That is not a value that is common. Remember, common value would be 0.22 or 0.27, okay? 0.25s have not been made in many, many years. So if you go on eBay and you find some 0.25 microfarad capacitors, 99% chance those capacitors are as old as the ones that are in here, and thus I would recommend replacing them. Similarly, they're using a 2.0 microfarad. That's not a common value. 1.8 is a common value, 2.2 is a common value. And here's kind of my approach to this, okay? If you're talking electrolytic capacitors and you can't match the exact value, I always go up one in value. So let's say I found a 45 microfarad electrolytic. I would go up to the next value, in other words, a 47 microfarad capacitor to replace it. With coupling caps, I typically go down one value. So instead of the 0.25, I'm going to go with a 0.22 microfarad capacitor here. I've done this for years, never really noticed any significant issue. It changes slightly the roll-off frequency feeding into a stage, but I think it's negligible, and so some 0.22s will be fine here. With the 2.0s, so that's an interesting one. I happen to have laying around here some 1 microfarad at 400 volts. This one becomes a little easier because I can parallel two 1 microfarads and end up with what? 2 microfarad. Remember, when you parallel capacitors, they add. So I can put two 1 microfarads in parallel and solve for this one. Here again, I'm going to drop in a 0.22 in this place. All right, that's the approach I'm taking. Oh, we got another 0.25 here. We're going to have to replace with a 0.22. It's the approach I'm taking. You can pick your own, and I'm sure what I just said is highly subjectable and debatable, but it's the route I'm going. A couple approaches to unsoldering circuit boards like this. You know, one, you could use solder wick with your soldering iron. Two, you could use a solder sucker of some kind. Those are all valid paths. I personally absolutely love my Heiko FR300 here, solder sucking device. I mean, it is just absolutely amazing. You get it on there, get your solder hot. Next thing you know, you're kind of sucking all the solder away. Next thing you know, you just pull the component right out the other side. It's super easy, and it is it is my choice of how to do this. All right, there's also page 17 of this manual. So these are slightly different between the two here boards, and so 17 goes to this board and 13 goes to that one. For the 0.22s, I'm going to use some Panasonic. These are polyester caps, not polypropylene. I think the polyester tends to yield, quality vintage sound, much like the Bumblebees, more so than anything else. But that's a personal preference, highly subjective there again. To each their own. You can go order your own 0.22 microfarad coupling capacitors in whatever flavor you happen to like. This is what I love about flat nose pliers. For a long time I used a pair of cheap ones. I finally picked up these Tronex, and I've been in love. But you just kind of clip and bend, and you get your straight little leads out there. You can stick this in one hole here on one side, and I'm having a hard time holding this. You kind of figure out where you need the bend on the other side, and then you come along and clip on it right there, make that downward bend like that, and you've got a nice capacitor ready to drop right down in the holes here. There we go. Melts perfectly in there, and then I can just straighten it up a little bit. And you just come along on the back side here and snip the leads off the back. And as you can see, in there just the way we want it. I'm going to keep working my way through. You can see what I did here. I installed one capacitor, and then the other one I just kind of tucked underneath of it and bent the leads around. And what I'll do is solder these off on both sides, and then that way I'm not trying to stick two lead ends down in a hole only made for one, and yet I've still paralleled the two capacitors here. As you can see here, I got these soldered together, and now it's just a matter of coming on and using my wire snips here to get rid of the longer leads sticking out on the ends. There we go. Two capacitors paralleled with each other. You notice this little booger here is kind of strapped down by the spider legs here of this wire. I'm having to kind of work it out from one end here, as you can see. You'll notice how I kind of bent this one. I did it this way so I can still get in the two holes. I'll have it somewhat centered here in the middle of this capacitor, but the capacitor's not sticking up in the air, and I'll show you when I get it inserted why. So you can kind of see now I did it like this so that this capacitor would lay down flat on its side and not be sticking up, because if it was, I would have never gotten it underneath here with these wires the way they are. So it's just all about fitting it appropriately. Interesting, if you look at this, it is a 50 microfarad NP, non-polarized, is what came out of this. Yet when I look at the schematic here, it shows a polarized capacitor here at 10 volts. And this, by the way, was a This was a 15 volt capacitor. So I'm starting to think at some point this may have failed and someone replaced both of these in here with some non-polarized they had on hand. It's got me questioning now, so I'm going to go back to the schematic and see what I find. So you can see here on the schematic, the 50 microfarad capacitor here is an electrolytic. It is polarized. It has a negative and a positive. So at some point someone had replaced these caps with some non-polarized, which is okay, because non-polarized can replace a polarized any day of the week. They're typically just fairly expensive, so I'm assuming someone had these laying around. At any rate, we're going to go find us a, keep in mind I'm not going to find 57, so I'm going to end up, 50, I'm going to end up using 47. And I know a minute ago I said I typically tend to go one step higher, but the next step above 50 is 68, and we don't want to go there, right? So that's quite a bit of a difference. Oh yeah, back on this 0.25 versus a 0.22, let me give you the options here. It's 0.25. So let's think about this. If I bought a brand new 0.25 microfarad capacitor and it's a 10% tolerance capacitor, and let's say it's 10% low. So that 10% of that, right, this would make that a 0.225 capacitor, right? And let's say I bought a 0.22 capacitor that was 10% high. That would be a 0.242. So you could have bought brand new one of these and a brand new 0.22, and the 0.22 might be higher value. We're dealing with 10% devices in most cases on these things. If you'll notice here on the board, it'll show you on the capacitor that one end of it is positive. It's actually got it marked here. So I'm going to, I've got some Nikon 47 at 50 volts I'm going to put in here. These are always good caps. Okay, as you can see, I'm going through here checking, like this is a 100 ohm resistor, it's 101 point, so it's 1.56% off. I'm not going to replace that, and I just kind of go through here and check them all. Every once in a while you'll find one that's in parallel with something else, and you're kind of scratching your head saying, you know, can't really measure it that way. And sometimes you'll notice, see what it's doing here? You're charging up a capacitor somewhere when you see this using your voltmeter, because somewhere there's a capacitor in parallel with that. But you know, this is a 68k ohm resistor. You're here at 65k ohms, and somewhere we're paralleled with the capacitor in parallel with it. That one will be fine. But you get the idea here. If I find one more than about 15% out of spec, somewhere around 10 to 15%, then I'll replace it. Otherwise, I like to leave the old carbon comps in for their tone. Just use an old soft bristle paintbrush like this to try to clean the board off when I get done. It's just years of dust settling on these, and I'll use a little bit here to clean the tube sockets, maybe a little bit of cleaner or something, but you get the idea. The other thing I like to do when I'm doing this is I check all the solder joints over here. Just like I mentioned a while ago, we had a component that had a, you know, wasn't even soldered in good, so I will check all of these before I basically do a reflow job using my like I see one right here that's not great. I'll end up reheating that with just a little bit of solder and reflowing that one. Okay, I'm done with this board. I'm going to jump on to the next one. Okay, this one was a little harder to complete, mainly because this umbilical cord that goes over to the power supply here is kind of tucked underneath this metal piece, and this thing has some sleeves down on here that are crimped on, and I tried getting them off. It wasn't an easy, trivial task. So at any rate, I ended up just working with it in this tight little spot here and got it done. It did turn out quite well, just like the other one. Keep in mind, this one has an extra capacitor right here on it. And I got one end soldered down here. The other end, though, is where a wire connects, and the solder blob here is gone, the pad in the middle. So what I'll end up doing is bending this over when we get it done, and I'll solder it to the wire that comes through right there, and that's kind of what had been done before. That place I showed you where it was loose, that's what was playing out there. So you see, I'll just bring that wire through, and then I'll solder it off on this. Now what I've got to do is go back to my PC to those pictures that I took. If you remember, I took a lot of them because of the wiring of this. And keep in mind, it's been about 4 months since I I made video number 1 here, so video number 2, I don't remember. That's why I take a lot of pictures, and we're going to start trying to get all this wire back up. I'm telling you, this is the ugly part. It's putting all this stuff back together. I imagine this will take me an hour or 2, but at least now the board restorations are done. Okay, first thing we're going to do is just get these boards back down onto their lugs here so they're good and solid, and we're going to put our 4 screws back in to hold these back in place. Because keep in mind, any soldering we're doing at this time is from the top down here, or the back side down. Alright, we got both these boards turned and mounted back down, and we've got all the wires pulled around it on the side out here so that we can start connecting them back to where they go. Wasn't as bad as I thought to get these back in. As I've been spinning these around, trying to get them back in location or whatnot, I've had, you can see here, a wire broke here, or unsoldered. I had another one here come unsoldered that was connected onto this. I think what I'm going to do is just get these pots mounted in here, and I'm gonna kind of do my own thing here with running these wires. These are old little brittle wires, and I think I'm just gonna unsolder each one of them and use some fresh PTFE silver-plated wire and run down in their place. Except for this ground bus, I'll put it back together. Also, while I've got these turned up and where they're easy to get to, I'm going to go ahead and get some deoxit in each of them. Get them worked really good on each end here to free them up in there and kind of clean up all the gunk. You get the idea. Okay, at this point we've got all 4 of the pots mounted back in place, nice and neat, and just tighten them up on each end. Make sure you get the washer on the ones going out like this. There's a washer that goes in behind. If not, you'll end up with a really tight, it's really hard to turn, but we've got all these set up now where we can actually turn them. And I'm struggling with this ground bus a little bit. I soldered it together right here, but I just don't like it. We'll see what we do with it here. Okay, a couple things I did here. One, I soldered this little black wire down from this point right here, which is actually the top tab here on this pot, down to its spot right here, which is actually ground on this board. The middle wiper, which is red here, comes down and goes into the very first little hole here, and I took lots of pictures. If somebody needs these pictures, I can gladly share them with them. And then the last one here, oddly enough, this white line feeds all the way over and comes over here and tabs off the mono stereo switch here. I opened these blades up a little bit, as you can see here, because I wanted this ground bus to be able to flow freely through here and not be pinched by them. Because if this is grounded to the chassis and this ground bus is not, it's a floating ground. And so if this would have worn or something and cut into this little blade here, you would have ended up with the non-intentional grounding of the ground bus here. So I've opened that up and given plenty of room for those to flow in between. And we're going to keep moving along. Okay, up next there's a purple wire that comes over. Looks like it comes from a terminal strip right over here. And we're going to bring it over, and it tags into a little almost L-shaped pad right here, and we've soldered it in good. Okay, up next we've got this red tube, and we've got a, looks like a black or a blue wire that comes out of it, and a brown wire. The short one here, the black or blue, whichever color that is, goes into right here where it says R, into this little pad. And it looks like the longer one will end up going where there's a little T marker. There's a T on the board right here. It might be hard to see because of the lighting here. But it's going to go into a pad right here. Okay, we got the blue one there, and then we got the brown one soldered in here onto this tab where the T's at. And then we're basically going to repeat this thing on the other side. Instead of the purple wire here, we've got a yellow wire we've got to wire up. Okay, yellow wire goes here on C. You can see the little marker C. Then there's B here, and that's where the red goes, and the red goes down to the center of the A input jack here on the side. And then there's a black one that goes to kind of the very edge here, which is the ground plane, and it ties up here into the ground bus. really tough to see here, but coming off of one edge of this wiper blade right here, we go down and we tie off on F where my finger just touched out right there. It's just a lot in the way of the camera here, but I think if you're working on it, you'd see what I'm talking about. Sorry for the shaky cam here, but it's about impossible to see any other way. There's a little wire that comes from the very right side of this wiper on the, let's see, that's on the bottom pot down here. And it comes across and it ties in right here to this, let me see if I can point to it another way. Ties to this little pad right here. This little bitty black wire. It's just really hard to see, and it's a little bit gunky there, the insulation coming up, but you can see I had to tie it down there. I had to go in and trim that insulation up. It was just kind of hanging off there, bugging me. But we got that in. Now we got these two here left. Same deal as last time. The little black one goes here to the R pad that goes across, and the brown one comes down here and goes to the T pad right here. And they're both soldered in now. Okay, let me show you what I've done now. There was a little orange cap right here. That was an older orange drop. Might have been good, but it had been kind of soldered on or glued on one side. It left me a little weary, but it says 0.25 at 200 volts. At any rate, the reason I changed it is because if you remember, one of these boards had an extra 0.25 on the input, and we changed that to a 0.22. And what it is the other one doesn't have it on the board because it has it up here coming off of the switch. So basically, you come in through one of these switches, and on one of these you go straight to the board. On the other one, you come in through one of these switches and you come up through this mono stereo switch here. Then you come out the other side of it through this now 0.22, and then that brings you down. That actually comes around over here through this white wire to the other side. So this one has it built in on one side. The other one hangs up here. Again, sorry for the shaky hand cam, but it's the only way I know to get the camera in here. If you'll notice, the bottom of this pot, I've ran a solid wire. I didn't use stranded here. And it goes down to this little pad labeled N right there. And I'm going to have to do the same thing up here on this pot. There'll be this bottom tab right here, and it'll run down here to this pad underneath there labeled N. Maybe you can see there what I'm talking about. I kind of ran down from that bottom lug down to the end. Then you can kind of see here I tied the middle lug here off to this ground bus, and I used some wire coming up off of it to kind of bridge the gap here. Wrapped it around and soldered it all good. So that broken point I had in this bus, figured out how to solve that. Kind of two birds, one stone thing here. Okay, and then lastly, coming off of this pad here, which is actually labeled S, it comes up to the very top tab. So middle to ground bus, bottom down to the end pad down here, top to here, and I'm going to do the exact same thing here on this other side. Okay, I think I've got them all wired up. I ran this red wire here down to this little S pad. So hopefully I've given you enough here you can follow along. If you have to do this yourself, you can do so, and I'll try to save all my pictures. If somebody needs them, just email me. I'll put them up in a folder for you. At any rate, I think we're at a place now. A couple more things I want to check though. Okay, what I've done now is I've got two multimeters wired up here. I've got speaker outputs tied in over here. And I've got one of these meters across one of these cathode resistors. Keep in mind, this cathode resistor 260 is shared across these two tubes, and it's also tied in with these two pots, right, or one of these pots right here. Similarly, over here on this side, it's tied in with one of these pots for the actual biasing or balance between the two output tubes. At any rate, I'm just going to check them across here, kind of my old school way of doing it. And we're going to bring this up slowly on a variac and see what happens. Okay, and I'm not sure if you can see, but we've got 28.9 volts bouncing around just a little bit here on one side. And we've got 28.9 volts on the other side here. So Remember, I'm measuring the voltage drop across this cathode resistor, and that's 260 ohms. I'm not sure if you can read this or not, but I did the math for you here. It's 28.9 volts across the cathode for 2 tubes. It's a 260 ohm resistor. 0.111 amps, or 111 milliamps, divided by 2 is 55 milliamps per tube. If you could pull up the 6L6 data sheet, which is what I'm running in this, 0 signal for a push-pull, 120 milliamps for 2 tubes. That's maximum. So we're within that. We're at 111 versus 120, or it's 60 milliamp for 1 tube, and we're at 55. So we're in good shape here. I'm happy with the balance here. I'm going to show you more in an upcoming short video on these jacks right here, and what I don't know if you can see them, but what I do not like about them, and why they're a horrible design, and why we're going to redesign this part of the amplifier. But I thought I would do that as an add-on so that someone doesn't have to watch this entire video to kind of get the effect of this. Okay, as you can see, 120 volts here, 2.36 amps we're drawing. Let's pan on around here. You can see here, I'll zoom in on it. Nice signal output here. This is at 24 volts peak to peak here on the output. Check out this sine wave. That's both channels superimposed on top of each other. I mean, that's as beautiful and as clean as I've ever seen balanced between the two channels. Alright, distortion on the left channel, 0.093%. Distortion on the right channel, 0.1%. So, for a tube amp of this age, I'm extremely happy with that. Can't be any happier. And up here on the 3582 primary, I mean, there's like literally no secondary. I mean, I'm so far off scale at this point. Let me try to bump this up. Amplitude 0.3 volts. As I bump it up a little bit there, and I'm driving off scale, I'm at 16 volts here, you can see. You know, these secondary and third harmonics here are so far down. Absolutely beautiful here. You see I'm driving it harder here at 36 volts peak to peak here, and it's still just superimposed over top of each other. Absolute beautiful signals. Let's see how this unit does with a square wave. Got a little bit of overshoot and a little bit of ringing there on the square wave. I'll have to put a little bit of thought into it. Could I clean that up a little bit? But it's not bad. It's a nice tight square wave. The slew rates on it are extremely low because we got super sharp verticals there, but just a slight bit of ringing on the front end of each of these. And that could just be output transformers as well. Okay, last but not least, let's see how it sounds. It's amazing. I don't know how else to put it. I couldn't be any happier with this. Thanks for watching this, everybody. Had a lot of fun with it, and hope you guys did too. You know, if you ever get a chance to pick one of these up, you know, they touted it back in the day, the MC 240 killer, because you know, it runs kind of a 6L6 EL37 Similar to the Macintosh MC20, which was the 7027/6L6. But at any rate, the value for the money, these rock stars. Absolutely great amps. Pain in the ass to work on right here. All these pots and getting to things. But the electrical part's not that bad. I mean, it's mainly just getting to stuff. But outside of that, I'd say own one and play the heck out of it. There you go. Thought I would show you what it looks like without the cage on it. It's got the 4 6L6s in pairs here. Each side of this has a beautiful Amprex Bugle Boy in it. You can see these can caps. They're in black. Like I said, if I did it again, I probably wouldn't wrap them. I'd probably have the silver up here. I think that might have been my mistake. You can see here the EF86s and the 12AX7s there on the unit. Let's see what it looks like with the cage on it. And there it is with the cage on it. It's beautiful. Heavy duty cage. Got the Knight logo. I love it. Glad to be getting to some of my own gear finally. And not just customer gear. I know it makes you guys sad when I don't take on work of yours. But anyway, I still do need to make this second video. So stay tuned for the mods to this amplifier. We'll make that next. Thanks for watching, everybody.